Okay, so we can start with the next phase, I would say, because we are still in the compile time. We are be talking a little bit. John will be talking a little bit about type safety, but mostly about his recent work. John is in Scala community actually since 2004, so like, whoa, quite long.
Not as long as Julian.
Not as long as Julian, yeah, almost as long. And you also met John yesterday during the discussion panel. John is also organizer of Scala World Conference, which is held in September this year as well. So let's welcome John.
Thank you. Thanks. It's good to see you've multiplied since first thing this morning. Who didn't make it to the first talk? A few of you, I think. So I'm going to talk about Rapture today, which, as Hao-Yi Lee noted a couple of days ago, has nothing to do with DevTools. This was his kind message. Thanks for that, Hao-Yi. Maybe I will try and tenuously sort of link some DevTools references into the talk later on, but this will be the novelty library talk at the DevTools conference rather than having just a novelty DevTools talk at a libraries conference as we normally have. I'm going to go quite fast because I ran through this as a practice this morning and it took me the full 45 minutes, and I know that I go slower when I'm talking to an audience. So I'm going to jump straight in. By the way, who here has heard of Rapture? Okay. Used Rapture? Oh, okay, there's a few, okay. So for those of you who didn't put your hand up at all, Rapture I normally describe as libraries for everyday programming tasks, the sort of things that you might find in a standard library, but written very much with a Scala style to the code and the APIs. For me, it's actually, for many years it was an ongoing experiment. It was a place for me to try out new ideas, experiment with new features, and see how I could build in some of these features into useful APIs that could actually do better than other libraries were doing these same sorts of things. Somewhere under, there's a button under there that I need to press to get to the next slide. I hate Dell. Space, no, space doesn't work. Right arrow? No. Just wait and it goes away. There we are. And I describe this as code at the intersection between, on one hand, type safety, which is sort of the most important thing about the libraries I provide, but also providing that with beautiful syntax that you can read and understand and have a good idea just by looking at it as to what it does without any boilerplate or any distracting parts to the code that take something away from the understanding of it, and that's almost sort of the definition of elegance in a Scala context. Someone did very, very kindly say that Rapture could be the next Guava or Boost for Scala. We're not there yet, but I would aspire to this as being whatever your opinions on Guava and Boost are. I would aspire to being this sort of category of library for Scala. So that's where I'm headed. So what's in there? I've talked about everyday libraries, but what are these everyday tasks? Working with JSON and XML, that's something most of us do. I/O, reading and writing from disk, from the network. Cryptography. So we have some tools for working with Java's cryptography API in there. Web and HTML. Now this is there are web frameworks out there. There's Lift and there's Play. They tend to be sort of large, integrated, almost environments for working with producing websites. I've gone for a much more lightweight approach. I have an HTML library. I have a module for serving pages, an HTTP library. So I'm very much not trying to build a single big integrated solution. I'm building a collection of tools that you can find useful for very individual tasks. And certainly if you use the HTML library, there's no obligation to use the web library, or vice versa. There is a module on internationalization. There are command line interfaces, both for interpreting commands that a user types in and for calling out processes, calling out the processes through the shell. There's a tiny LaTeX module. There's a module for working with CSV. I've just started working, after years of thinking about this, on a time module and an email module. So all of these things are things you probably want to do in applications at some point. They're all individual modules in Rapture, and they all share what I think is a similar philosophy. And I've tried to distill this philosophy into 6 key points. And well, I'll talk through them. I want the code to be intuitive. I want you to be able to read it and understand it. I want it to be extensible in different dimensions. And I know different people do things in different ways. They want to integrate with different libraries, different types. And Rapture provides lots of, the philosophy is to provide lots of extension points where you can develop alongside Rapture in your own direction. It should be configurable. Not everybody does things the same way. And there are choices to be made. And Rapture has a very particular way of dealing with configuration options. Unopinionated. Now, this was a word that Rob Norris or T. Polecat suggested to me. I try as hard as I can to avoid forcing you to use certain dependencies. I'll give you a good example of this with the JSON library later on, but I don't say the JSON library in Rapture is a meta JSON library. It doesn't do the parsing, it doesn't do the ASTs itself. It lets you choose which backend you want to use. So you can use Play, Spray, Argonaut, whatever you like. And this is what I mean. It's unopinionated in the choice of backend you use. Now this word idiomatic, this sort of raises some eyebrows. What does idiomatic mean? Well, there is very much a Rapture way of doing things. Now I'll sort of describe a few points around this. It's probably easiest if I go through those later. I know that there's some concern over what it means to have idiomatic Scala. People talk about it, and then nobody really knows what idiomatic Scala is. And I think everybody has a slightly different opinion of what it is to be idiomatic. Hopefully, the idiomatic Rapture can be better defined. And the most important point, the most important part of the philosophy is that the library should provide type-safe APIs. And in fact, to go further than most other libraries do, to offer something more than a typical library in the constraints it enforces on your code. I've just got an email from... that's from Eugene. He sat there with his arms crossed. I don't even know how he did that. So the first point, intuitive. Now I'm going to give you some examples. Oh, go away, Dell. I don't want to install these updates. Oh, I've lost it. There we are. So I'm going to show you some examples in the REPL. We've got live coding. So by the way, there's a whole lot of prelude you can't see here that it does first, but we've got a JSON value there. And this is just some JSON that I wrote representing the candidates in the US election. Oh, Valentine's Day flowers, 5% off. Oh, okay. I wish I could turn all these notifications off, but it's actually harder to turn them off than it was to turn them on. Now, in Rapture, you can simply reference the path through the JSON to access the element you need. Now this, I think, is very intuitive. At the end, you specify the type. And here we've got the age of the third element, which is Marco Rubio. He's 44, and we've got that as an integer, and that's a Scala integer that we can that we can use. We could access other elements in here, but that's so. By the way, each of these little demos will be tiny, and you may want to ask me afterwards whether you can do X, Y, and Z relating to that. But they're all going to be brief, and I'm going to move on quickly to the next one. So any questions you have, probably because time is limited, save them for the end or try and catch me later. But back to this slide. Other things we can do. So that was an example from the JSON library. From the I/O library, we can talk about resources. So one such resource is a URI. So we can write a URI like this, and we simply put it inside a string prefixed with the letters URI. And there we have one. And it knows, because I typed HTTP there, it knows that it's an HTTP URL. Now that might not sound too interesting until I show you that. Actually, let's just put this into that value there. Let's say file equals, now I can create a file as well, which this is on my local disk, and for some reason I've got a list of the top 1,000 German words, which is this file here. Now this has come back as a file URL because it knows it's seen that it's a file. So this is some interesting typing going on. Now that's quite a nice way of referring to resources. Now, given one of those resources, we can for example load all of that into memory. So I can say file.slurp, and I'm going to slurp that as characters, and it's just pulled in the entire file as a string, and those are all those German words. Now I can do exactly the same thing, exactly the same API, with the HTTP URL as well, as long as I've got a network connection. Do I have a network connection? I do, yeah. Okay, so it's just maybe it'll be faster next time. Yeah, okay, so that's downloaded the homepage of Google. If I wanted to, I could load that as bytes. That's what when it finally loads. This is that's what the Google homepage looks like when it's pure bytes. I don't know what all the numbers are in the in here. Presumably that's a very efficient way for Google to represent something in the. Oh, okay. Yeah. So we've got this very consistent APIs. They work the same on files. They work the same on URLs. You can also refer to class paths. You could refer to FTP URLs. You could refer to S3, Amazon S3. And it would be the same API. As long as the thing is readable, you can read it into memory. And of course, you can do other things as well. You can, for example, get an MD5 checksum of that. And if you can read it, you can get the digest. We've got the Internationalization library, which means we can represent some number of, or we can represent a string in a number of languages and have that as a single value. So this is kind of like a map. But I'll show you later why this map is a little bit different from the kind of maps you get in at runtime. But we'll see that later. And the HTML library, this is a very, very simple representation of an HTML page. It's quite concise. There's a whole page there on one line. And I'll show you why that's what's special about the HTML library once I get to the Typesafety slide. And one more example. By the way, the ones with little red stars, I have examples on. This is to remind me that I need to show you something. So given our JSON value, there it is again, we can get one of the elements from that. There it is. And we can, for example, add an element to it. Now, the syntax for this is this. And we've created a new JSON object using very concise syntax, and I mean we can add other things as well. So we can say we can use details dot from equals he's from New York, isn't he? So we can do that, and then it breaks. Oh, that was working earlier. Maybe. Yeah, it's from New York. That's what I meant to do. This is what happens when I deviate from my script, which is over here. Anyway, we can quite easily modify the JSON as long as we avoid the I think the problem was Donald Trump. It's his fault. And if we wanted to work with a shell command, so this is, we can write a shell command like this. Now ls-a gives us a list of all the files in a particular directory. The current directory happens to be my home directory, but I can then execute this by just getting that as a list of strings. Now this gives me, this basically converts the lines in the response from the shell command into a series of elements of a list. So this is a really quick way of calling out to a process. And I mean, we get the whole thing as just a plain string. That's what it looks like when it's just a string. And I mean, we might want to try and get it as an integer, and that will probably fail. Oh no, that's the return type. So we get a successful exit type. So what do I mean when I say Rapture is extensible? Well, let's take the example of trying to, let's go back to Donald Trump again. I like Donald Trump in some ways. Now, we can get his date of birth. Now that we can see is long. So we can get the value out like that. That's fine. But we might like to get a date. But we can't extract a Java util date from Rapture. There's no standard way of doing that. And that's kind of correct. There's no universal way that people have agreed on for accessing dates. But I'd like to access dates directly. So what I might do is define my own extractor. So I can do this. My extractor. Now what I'm going to say is give me the extractor for longs. Because I know I can extract longs. That works. And then, because it's a functor, I can map that long to a new date. Now I've now got an extractor for dates, and this exact same command I ran before will now work. And we find out that he was born in 1944 on the 14th of June. So that is how we can extend it, and that's just a one-liner to define extractors for a new type. Can you tell us the Stone Age joke?
No, just should have been born in the Stone Age.
Oh right, yeah, or shouldn't have been born. I don't know. Am I getting too political? Oh God, come on, somewhere under there. You see, I can kind of turn it off, but right. We can also. I'm not going to show this this demo, but I mentioned before we can define a URL scheme for working with S3, and we define, for example, an implicit class, and that allows us to basically call a. I'll show you what doesn't work, but URI. If we wrote that code, we'd be able to say URI S3 is some bucket / foo bar, whatever. It's unable to, you can see there it's looking for S3 as a scheme name, and we can simply provide that with this implicit class. We can also define complete backends for JSON or XML, and this is something somebody else has done. I did the 8 JSON backends that are in Rapture, but someone else has worked on this and found a use case for another sort of quasi-JSON backend they wanted to work with, and they were very easily able to implement all of the methods in that type class and to be able to use the nice Rapture JSON syntax on their backend. We can define capabilities on all of the I/O resources. So I mentioned getting digests. There are other things you can copy files, you can check their size, but if you define those capabilities in terms of other capabilities. So for example, if you define the size in terms of reading a file, I mean, this is the worst case scenario, but if you wanted to check the size of a stream, you read the whole thing and see how much you've got, and then return that as a number. That's one way to check the size. You can provide more efficient implementations of that, but it means that if you can read something, you instantly get the ability to do all these other things as well. We can define how errors are handled. I've got a slide on this later, but Rapture gives you some good ways of choosing your error handlers. Do you want to return a try? Do you want to capture things in an option? Do you want to just throw exceptions? Is that fine? These are all possibilities. We could define our own tag libraries for HTML or HTML-like languages. So we could, for example, implement the the SVG language in tags and attributes, and that would be basically one line for each element, one line for each attribute type. So on to configurability. There's a few of these, and you'll notice that each of these configuration options is an import. So you can import an encoding that you want to use. Now that applies to all of your character streaming based code. You can specify your error return type. You just import modes.return try, and then a lot of your failing methods will, rather than throwing exceptions, they will return try instead. We can choose how, like subtle ways that behavior works. So for example, how pattern matching works in JSON. We can pattern match against JSON, but do we want to pattern match the whole thing? Do we mind if there are spurious elements that are in the thing we're matching against? Or do we want it to be literally exactly the same JSON? These are options, and they're configured by imports. And the benefit of imports, and this is importing implicits, the benefit of this is that we can scope them. We get complete control over where that configuration applies. We can put it at the top of a file and it applies to the whole file. We can put it in a class and it applies to the body of that class. We can we can alias it in a package object and then it applies to the entire package object if there is if it is that global. Or we can put it in literally in the body of a method and it only applies there. I'll give you a quick example of this. Date formats. We can create a date. So let's say this is how you write a date in Rapture. You write the day, you write the month, and you write the year. And we've got a date. Don't be so surprised. It just happens to be easy, and then we can format that date. But we don't have a date format, so let's import date formats dot short US. So this is going to be a short US format, and obviously now we have to be careful because this is not the 15th month. It is the 3rd month, and then the 15th day, and the 10th year. If we imported, for example, long European, we do the same thing, and we get a more sensible ordering. And oh, come on, it is no, a more sensible ordering of the day, month, and year. Eugene.
So I have a question. How come you're not getting ambiguous implicits or something?
Okay. The answer to that is a very good question. Well spotted. The answer is quite long, but it's due to shadowing, and I wrote a blog. So if you notice, I actually import _, it's short US and long European, and indeed all of the implicits import _. All the implicits of a particular type have the same name inside those objects. The one I import last shadows the one anything before that, so it means you can repeatedly import more and more, and you don't ever get ambiguous ones. I did write a blog article on this, which is on the Rapture.io web page. So, what did I mean by idiomatic? How am I doing for time, by the way? Is that 15 minutes to go? Okay. So, this idea of using implicits and imports is very, very typical Rapture. The extensive use of type classes for ad hoc polymorphism is basically where I normally go to type classes before inheritance now. It used to be that I would think about inheritance hierarchies. Now I don't even bother. I go straight to implementing things with type classes. Rapture has very precise exception handling. What I mean by this is that part of the signature of methods includes in the return type the kinds of exception that method might throw. Now, most of the time you won't use this. It depends entirely on the mode you're in, whether you can take advantage of this. Now, I'll explain modes in a couple of slides, but essentially, it gives us an ability to be much clearer and much safer in forcing us to handle certain kinds of error. And another point, as a very general way of doing things, I prefer types over values for many things. So if I go back to the example before, if I write my my message, which was either hello or in French, bonjour, or Polish. Now tell me if I've got this correct. Dzień dobry, like that. Are you clapping because I put the accent on the N? Yes. Right, I practiced that. So we now have this message, but rather than accessing the English value with a value like that, we actually give it a type. So we can get the English value like that, we can get the Polish value like that, we can get the French value, but if we try and get the German value, because it doesn't have a German value, we know at compile time that this will not work. The map at compile time knows that it doesn't contain this particular value, so it will fail before we fail at runtime. Back to the slides. Oh, I've clicked on the wrong one. Right, unopinionated. So, why would we want this kind of flexibility in dependencies and all this choice? People often like to be told what to do rather than having too many options. Well, there are reasons. Dependency management in Scala can be complicated. You can have two different libraries, both of which depend on the same library but different versions of it. Now that's very difficult to resolve if you want to use both of those two libraries at the same time. It's like the diamond inheritance problem. So one solution is to just not use one of those libraries in your in Rapture's case, for example, in the JSON backend. So what we can do is choose a different one. So we can change dependencies. There might be bugs and features that we discover in certain of these libraries that mean we want to try something different or stick with a particular version. Or licenses. I don't know, Sam, if you know whether or what licenses different JSON libraries for Scala are available under. Are they all actually Apache 2?
Almost everything is BSD. That's why I would like everyone to move to Apache.
Right. Okay. So you might prefer an Apache licensed JSON library over a BSD licensed one. So there are reasons why you may want to have this choice. And for Rapture JSON, we have a choice of 8. We do Jawn, Cersei, Argonaut, Play, Spray, Jackson, JSON for S, and Lift. If that's not enough choice, then I don't know what is. And just a very quick demo of this. If we import one of these, well, let's do Spray. And then we can sort of refer to, I don't know, let's have a list of one value. That's a value now represented by a Spray AST. Now there's not much evidence of that Spray because the Rapture JSON API kind of hides all those differences. What we can do is we can get the value out from inside it, and that's what it looks like in Spray. Now, if, for example, we use Lift instead, and we try to get that value out, you can see the representation is different. So just to be clear, as any is just a little way of getting at the value that's inside. You don't really want to use it most of the time, but it will show you the value that's inside that JSON. And as you can see, the representations are there, and they're dependent on the backend we're using. We could also support different time backends, cryptography backends, web server backends. We've got Jetty at the moment as a web server backend, but I mean there are many reasons to possibly provide other backends for the web server. XML only currently supports the standard library XML, but we could wrap other alternatives, logging and so on. And in particular, one particular use case is Scala.js, and we could offer backends that give us better performance natively on Scala.js for cases where those exist. So on to what I think is the most important important part of Rapture, type safety. We can write a JSON literal like this. We can substitute the value bar inside the JSON there, and it will only let you do that if bar is a suitable type. It doesn't have to be a string, it can be an int, it can be a case class. Any of those things will be fine, provided Rapture is happy to, or provided Rapture knows how to convert that into JSON. Here's an example with XML. This isn't so much type safety, this is more parse safety. Can anyone see a problem with this? Bar does not have a closing tag. Let me show you what happens. If I write XML, what was it, foo bar, it was like that, wasn't it? Failed to parse. This is compile time. This tells you before anything else happened, before you've even tried to run this, that this will not work. We had this already with inline XML in Scala. I mean, you know, I haven't tried this in a long time, but yeah, similar kind of problem. But we do this in a way which doesn't use the XML literals, which are being deprecated at some point. Now the HTML library is kind of cool, and I'm quite happy Lars Hoopel started using it today or yesterday, and has been posting all kinds of issues that he's found. But what I can show you, here's an example of what you can do with the HTML library. We can write something like this. That's our head content, and our body will be, let's put a table in. Let's just do that. So I've very quickly written some HTML there. That was all fine. Now what happens if, for example, I put an image in there? Can you nest an image directly inside a table? Yeah, let's try and run it. It's a type mismatch. It's not a runtime failure. It knows at compile time that images don't go inside tables. And the error message here, I think we can improve on. We can offer a better message there. But essentially, all of the HTML5 nesting rules are enforced by the type system. All of the tags have defined with them the elements that they can go inside and the elements that they can have inside them.
What about attributes?
The same applies to attributes. So let me show you an attribute. So an image source equals URI HTTP. Something like that. We still have the problem here that we can't have an image inside a table, but we can have an image straight in the body, and that will work, and that's what we get. You'll notice that also the type I included here is a URI type. So as much as possible, I use strong types on the attribute values rather than just strings all the time. An interesting experiment, which is kind of on the cusp of what the Scala compiler is able to compile without crashing, is encoding the structure of things in types. So I'll give you an example from the command line interface library. Now the command line interface library allows you to parse parameters that you might parse. So we can first define some parameters. So alpha is a parameter that I've set up here, beta, gamma, with 2 m's. And these are just really simple definitions of the type we're pulling out of this this parameter and how you specify it at the command line. So it's either dash alpha and then a string, or dash b and a number. Now let's say we wanted a parser which either accepts an alpha value, so you can parse your command dash alpha and some string, or you wanted to provide both, or you needed both a gamma and a beta. So we can literally write that code, and we get what is essentially a parser for that specification I just described, either alpha or beta and gamma. Now the interesting thing, and I won't show you much detail on this because I've already given a full talk on this, which is probably available online somewhere, but essentially if you look at the return type here, well, all of that includes a reference to gamma, beta, and alpha. So the compiler knows the exact type of this, and it knows that if we successfully parse some parameters using this, so this might fail or it might succeed, but if we succeeded, then it definitely conforms to that specification which is encoded in the type and which the compiler knows. And once we've got that specification in the type, we can know very useful things like we can provide a total function, we can check the type of a total function that operates on those parameters, and we can know that at runtime that has no risk of failing. Indeed, it will potentially fail at compile time with a compiler crash, but that's because of bugs in ScalaC. Somewhere around here. There we are, got it. So type maps for internationalization. I've got one more demo on this. I showed you how you could access the English, French, and Polish values, but not the German value where we specify the type. If we created a message and we specify the type as an internationalized string, and let's have some languages. We'll have English, and what else? Polish. Okay. Any other suggestions of languages that we should include in here? Any sensible languages? Russian. Okay. So we specify the type. Now, given the compiler knows what type we want, we on the right-hand side have to provide these, because if we don't, actually, what text should we have in our internationalized string? What? Thanks. How about let's make it a bit longer. Thanks for coming to my talk. Okay. But this is a type error. We haven't provided, and the error message we get is very nice. It says we haven't provided Polish or Russian. So it would be nice to do that. So I mean, I could ask you to translate for me, but I don't always have an audience in front of me when I'm coding. So what I'll do is I'll import Google Translate, and then just try the same thing and see what that happens. Okay. So the compiler has kindly translated this to. Okay, here we go. Jaki ja do mojego wykładu. Is that anywhere near? Okay. Or spasiba, что пришли к моей bеседе. Is it better than last time I tried to pronounce Russian, Eugene? that was a year ago. I'm getting better. So we can we can do that. I've got the stop signal. So I'm going to skip over error handling. I'm going to skip over some of the issues with Rapture adoption. I wrote a blog on this. You can go to the Rapture.io website, which is here, rapture.io, and read the blog on how I'm trying to get people to try out Rapture, play around with it, and contribute. There are reasons why we haven't had so much adoption. Part of it is the documentation. That's something we're working on. The website is now updated. It's no longer out of date. And Rapture, the M4 release is... Actually, the website is out of date because this says M3. M4 was out a day ago. So you can get the most recent release on there. We've got a few things that need doing. Like I said, more documentation. I would like the code to be more accessible so people can contribute. But in the meantime, I would like to encourage people to chat on the Gitter channel, speak to me if you're interested in working with, using Rapture or contributing. And we've had a lot of people showing some interest in the last month since I wrote my blog trying to encourage people. And it's been very exciting seeing that team grow. So if you want to become part of a growing team working on an exciting project, get in touch on Gitter or Twitter. I'm at Propensive on Twitter. The website's there. You can have a look at the source code on GitHub. we have an active issue tracker, which is quite colourful. There are lots of these issues marked as easy. That would be a good place to start if you were interested in contributing. And I will very, very quickly go through the roadmap. We're hoping to get a release, a final 2.0.0 release this year. We've just released M4. In a month, we'll add more features to that. Then I'm hoping to improve the stability and fix some bugs and add more testing to it. We hope to API freeze on the modules that are currently most complete, which is those, and then maybe a month later we'll have the others stable. More testing, and then hopefully we'll be at the stage where we can offer release candidates in August, and then finally have that release in September in time for Scala World, which I hope some of you may come to. We had a great time in the Lake District last year, and we had almost 200 people. We're going to be a little bit bigger this year, but we've got once again an amazing program of speakers. The website is you can see the entire thing there now. That will develop over the next couple of months, and I think tickets will go on sale in March. So the website is scala.world. It should be easy to remember, and keep checking that. And I hope some of you will come. And that is all I've got.
Thanks, John. I think we could go on for one question if there is one.
Dare I? Okay, I didn't get any choice.
It's actually just a comment rather than a question.
Okay, fine.
In Enzyme, we've got the hackathon at the end of the day, and one of the things we would like to do is to use Rapture. So if anybody would like to try out using Rapture in the hackathon, then that's something we can help you do.
Okay, and to make it harder, I will be on a plane then, so I won't be able to help. But by all means, leave messages for me in the Gitter channel. Yeah, I might be at the airport then actually. But so yeah, abuse is fine too.
Was there a question also?
Surely,
Okay, so
surely must be one question. No? Oh, Julian, go on. You always say nice things.
Thank you. How much macro magic is there behind the scenes?
Right, that's a very good question. I've avoided macros as much as I can. I didn't implement the translation in types. That uses a macro. The error message, for example, which says you need to provide these languages, is provided with a macro. The custom URIs are done with a macro. A lot of the string context stuff is done with macros, so the parsing of JSON and XML is done with macros. Of the rest of it, I'm just going to have a quick look at the script I've got here. I think that's it. It's URIs, string contexts, literal JSONs, literal XML, and that magic with the translation. Everything else is done with types, including, for example, the tracking of the command line parameters, which is probably the most complicated type level stuff that's going on there, which is why it crashes the compiler occasionally. Yeah.
Okay, thank you. It's time for lunch, actually.
Thanks.